Hi children, this is Venkatamna. Today's class, 8th class Physical Science, first unit, 4th chapter. We already completed conceptual synopsis. Total conceptual things already completed. What are the force, what are the types of forces, and what are the various types of forces will come under contact and non-contact force, and what is the effect of force, and what is the effect of force on the motion of a body which is in a moving position, and is there any change in effect due to the contact surface area, and what are the applications of the forces which we apply, that we completed. Even we compared, we did some reflections on the concepts also. Reflections on concepts also completed. Now we are going for applications of concept. That means where we will use these concepts, how we will use these concepts. In that way, what you call, you have to go through that. In that applications of concept, first question. What the first question means? How can we differentiate between contact and force at a distance? The differentiation between contact and contact force and forces at a distance. Contact forces and forces at a distance. We have to differentiate. Mainly. Now, let us differentiate. What do you have answer? Contact force is applied by physical contact, by directly physical contact to the object. Whereas forces at a distance are exerted on the object, even though of the object which is going to apply force is in not contact with the object on which we are applying a force. So the main difference is, if A object is exerting force on B object, then in contact forces, A and B, A will exert force on B by direct physical contact with B. Without direct physical contact with B, A cannot exert force on B. A cannot apply force on B. Whereas in forces at a distance, if two objects are if A is applying force on B, even though A is not in contact with B, even though A is directly not in contact with B, A will exert force on B, even means from certain distance. From certain distance, A will apply force on B due to the field created by A, surrounding of A. That means it is nothing but a field force. So, example, in contact force, muscular force. If you want to push or if you want to pull any object, then we have to touch that body with the help of your hand or with the help of anything, and then only we by directly physical contact only we will apply the force. Whereas in a forces at a distance, magnet can able to apply force of attraction or force of repulsion, even though magnet is at a certain distance from the magnetic substance. Even though magnet is at a distance from the certain magnetic substance. In that way, magnet can able to exert force on magnetic substances. Similarly, if you drop a body, it will fall onto the earth because of gravitational force. Now, on this freely falling body, gravitational force is applied, but that gravitational force is not applied by directly physical contact with the chalk. Without directly physical contact, the force is applied on the chalk piece by the earth. So it will come under forces at a distance or field force. Because up to certain area, certain surrounding of a earth, a certain up to certain region of the earth, there will be a field created in which a body can able to exert force. Earth can able to exert force or earth can able to apply force. Simple. Contact force is applied or exerted due to the direct physical contact. Forces at a distance are applied or exerted without being contact to the body, being direct contact to the body. That's the main difference. Muscular force, frictional force, normal force, and tension force always will come under contact forces. Magnetic force, gravitational force, and electrostatic forces will come under forces at a distance or field force. That is the first question answer. Next, they are asking some diagram they give. They are asking to find net forces. They are asking to find net forces. So we have to find the net forces for the following diagrams. We have to find the net forces for the following diagram. What do you have diagram? Let us check that. Second, they give the figures like this. A. One block is there. One block. On that, 10 newtons force is applying towards right side. Even 8 newtons force is also applied towards right side. And opposite to this one, a 12 newton force is applied. So all these forces are applied along the x-axis. Along the x-axis. Now net force. First of all, this net force is equal to, as these two forces are applying in the same direction, so we will tell that 8 newtons plus 10 newtons. 8 newtons plus 10 newtons minus this opposite force. How much? 12 newtons. 12 newtons. Why? If the three forces are applied in the same direction, then summation of all the forces will come under net force. As this force is acting opposite to these two forces, and these two forces are acting in the same direction towards right side, so these two will be in the summation and this will be the difference. So 8 plus 10, 18 newtons minus 12 newtons, then 6 newtons is the towards right side. Towards right side. Why towards right side? Because these two forces are greater than the 12. So what is the net force acting on this block now? Now this block will move towards right side. With how much force? 6 newtons. 6 newtons force. This is a net force acting on this block. Net force acting on this block. Now let me go for B. What the diagram we have? Again, one block is there. On this block, 8 newton force is acting towards right side, and towards left side also 8 newton force is acting. Now, what is the net force acting here? What is the net force acting on this block? Let us find out. Net force is equal to whether these two forces are acting in the same direction? No, they are not acting in the same direction. One is from left to right and other is from right to left. As both the forces are acting on the block in opposite direction with the same magnitude, then the net force obviously will be zero. As a result, this block won't move any direction. This block will be at rest position. How? Net force is equal to 8 newtons minus 8. Why we are subtracting here? Because both the forces are acting opposite in direction. Both the forces are acting opposite in direction with the same magnitude. As both the forces are acting opposite to each other and with the same magnitude, that's why net force is equal to difference between the two forces. And 8 newtons minus 8 newtons, 0 newtons. Therefore, it will be at rest. It will be at rest. It won't move to any direction. Here, why it is moving towards right side? Because the forces which are acting from towards right side is greater than the forces which are acting towards left side. That's why the net force here is 6 newtons towards right side. In that way, we have P. Now, let us go for one more. C. C. So what is another question here? The again diagram here. Here, one block is here. One. On that block, now 8 newtons force is acting this side. And one more what we call same acting is 6 newtons force. 6 newtons force. And here 9 newtons force is now only these forces only act. Then what happens here? What will happen here? So here both the forces are acting in the same direction towards right side. Both the forces are acting towards right side in the same direction. Therefore, net force is equals to 8 newtons plus 6 newtons. Why you are doing summation? Why you are doing addition? Because both the forces are acting in the same direction. As both the forces are acting in the same direction, then total force, net force, is a summation of both the forces. That is equals to 40 newtons. Towards which side? Right side. Towards right side or towards east side? Towards right side. So this block will move with 40 newtons force towards this side. Now, in that way, we have one more diagram. So let us go for one more diagram. That is another diagram is there. Where we will discuss that diagram now means we'll go for once we copy this one, or else we will go for fourth one here. This is second question. Now we'll go for here. So what's the fourth diagram here? The D diagram. D diagram. Now what is the D diagram here? D diagram is again one block is here. Again one block is here. On that block, one force is acting vertically downwards and one force is acting vertically upwards. And in this case, what about the net force? What about the net force? Since both the forces are opposite in direction, therefore net force is equals to 9 newtons minus 8 newtons. That is 1 newton upwards. 1 newton upwards. With 1 newton force upwards it will move. So the block will move upwards with 1 newton along the y-axis. Whereas in all these three cases, all the forces acted horizontally. Horizontally means along the x-axis. Whereas in this case, the force is acting along the y-axis. So that's why since the vertically downward force is less than the vertically upward force, the net force is equal to 1 newton upwards. And the body will be in the air. In that way, we can able to find out net force depending upon whether they are acting in the same direction or they are acting in opposite direction or whether they are acting in horizontal or what we call vertical directions. So note down one sort of shape. So in this way, we can able to do the net forces acting on the object. Net forces acting on the object. Now we'll go for another question. Now what the another question we have that? That is, a man still stands on a level floor. Then what forces act on him? And we had to draw a FBD diagram. We had to draw a FBD diagram, free body diagram, and also we had to show what are all the forces acting on that man. That we have to show that. So what they are asking question? A man stands still on a level floor. Question. A man stands still. A man stands still on a level floor. On a level floor. Then we have to draw a period diagram. Then what forces act on that? What forces act on him? That we have to find. First, you have to tell, and you have to draw a FBD diagram, free body diagram. Draw a free body diagram to show all the forces, to show all the forces acting on him. Acting on him. That we have to show. So already we discussed this type of question in a reflection on concepts. Reflection on concepts. So let me draw for that man, which we will stand on a level floor. Level floor. It's a level floor. He is standing on level floor. Now, how many forces will act? His weight will act vertically downwards. His weight will act, which is equals to W is equal to mg. It is acting vertically downwards. Then from the floor, one force will act vertically upwards. This is known as normal force. So what is this W? Weight of the man. Weight of the man. Weight of the man. Weight of the man. And what is this N? Normal force. Normal force exerted or applied. Exerted by flow on a man. That is a N. And these two forces are equal. If these two forces, generally these two forces will be equal. That's why man is, since why, how you can tell these two forces are equal? Since man is in still position, since man is in still position, therefore, what is a net force? Net force is equals to W minus N, which is equals to 0. When the net force is equals to 0, then only he can able to stand still. He can able to stand still. As net force is what we call is standing still, already mentioned. Stand still. That's why net force will be 0. That means as these two forces are acting opposite in direction, the net force is equals to 0. That's why you can able to stand like that. Now, how many forces are exerting on man? Two forces mainly. We are assuming that we are neglecting the force applied by the atmosphere. Force applied by the atmosphere. Then we are assuming here the net force will be equals to 0. Net force is equals to 0. In that way, we have a this the free body diagram of a man, which is acting on the man. Just note that. So remaining concepts of application of concepts we can able to discuss in next class. Thank you.